In this video, I'm going to talk a little bit more about strings as a data type and the structure of the for loop Python. So strings are examples of a compound data type, and this is in contrast to the simple data types that we learned earlier, integers and floating point numbers. So a string consists of smaller pieces. Each one of those pieces is alphanumeric character. And sure, if you type out a long number, you're hitting the keys multiple times to make that number. But the idea is that in a number, the placement of each digit matters. So it could be in the ones place, the tens, the hundreds, and that influences the entire object in a way that this compound data type um, is not. So for compound data types, each smaller piece can be assessed on its own, whereas for numbers, not as easy to do. So in this example script here, a little bit of code, a variable named fruit is assigned a value, apple, so a 5-character string, apple. Here in the second and third lines, individual letters are being pulled out. So I talked about smaller pieces. This is how you reference them. So you write the name of the variable, and in brackets, kind of square brackets after, you use what's called an index. And so for letter 1, we're assigning it a value equal to the fruit variable and the 0th index. So we start at 0 in these indexes. It's just a convention of computer programming. So 0th is really the first, the leftmost in the sequence. And if we were to print that out, letter 1 has a value of A, or the leftmost character, the first or the 0th, just by convention, whereas the 5th letter is actually referred to using this index of 4, even though what you think of it as being the 5th. If you start counting with 0, 1, 2, 3, 4, it gets you to E. We saw the len function before to pull the length of a compound data object. So if a variable named fruit is assigned a value, the string apple, the function len, passing the argument fruit, will output an integer 5. So it takes as an argument a string or any kind of sequence, outputs an integer. And now you can put that variable, or this 5 anyway, this value, in as an index. So this code illustrates that. The variable length equals the output of the len function with fruit as the argument, so we know that's a 5. So then last, this variable is assigned a value. It's equal to looking at the variable fruit, so this is the string apple. We're going to look at a specific index, and that's going to be length minus 1. Length is 5, so 5 minus 1 is 4. Fruit, the 4th index of fruit, going to be assigned to the variable last. And if we print out last, it's going to be E. It's going to be the same thing we saw right here. But just be mindful that this index has to be an integer, but it can be an expression too. So length minus 1 is an expression that gets evaluated to 4. So here's something I had on the first slide, kind of just illustrating counting from 0 up to 5. Each index is assigned a letter, and here this string Python. And we can not only reference individual letters, but we can slice the string to take some of the letters out of that. We do that also by referencing the variable name and using square brackets, but inside those square brackets, you can include a start index, a colon, and an end index. So if hello is our string, capital H E L L O, assigned to a variable s, we can reference some of that string. This variable part is assigned this s sliced between the first index and the fourth index. And what is part equal to? It's equal to ELL. So no capital H, that's going to be the 0th, and no O, which is actually the number 4th here. Because in a start and end, the start index is included, but the end is not, and that's just a convention. The other way you can reference either individual or parts of a string is by using negative indexes. So here a -1 would be the rightmost, -2 the second from right. It's just counting the other way from right to left, and there's no -0. So I don't know if you could call that intuitive, but when you're counting from right to left, referencing parts of a string, you begin with the negative. So if instead of apple or APPLE, we assign the string BANANA to a variable named fruit, banana, we could reference up to the 5th index. So B is the 0th, A is the 1th, N is the 2th, A is the 3rd, the 4th, the 5th. I don't know, it sounds silly if you keep saying that, but it might help understand how to reference individual parts. And then you can think of the 6th index as being excluded. Here's an example how you might want to have an application where you have a longer kind of sequence of something you wanted to just pick out the names. So here we have a string, capital P eater, comma space, capital P Paul, comma space and Mary, Peter, Paul, and Mary. If you want to just isolate the names here, so not refer to this punctuation, the word and the space, you could do so like this. Print s, the name of the variable, and then to slice it, we use the square brackets, the 0 up to and but not including the number 5 index. And so that's the comma. That would get us Peter. For Paul, you begin on the 7th, and that's included. The second number you mention is 11th, but that is not included. There's the comma. And then for Mary, begin on the 17th character, go up to but not including the 21st. And in fact, there is no 21st here. The other lines down here show you that if you're slicing from the start or to the end, you don't actually have to pick out an index here. So if we get rid of that 0, get rid of the 21, the outputs would remain the same. The 0th or the leftmost is just, it's taken for granted, it's understood. Similarly, there's no 21st character here. So if you just end what's in the brackets with a colon, it goes right up until the end. So that would give us the same Peter and Mary slices. So you can print each character in a string, print it or assess, whether it's not a number or not, for example, using a while loop structure. Here you'd use an index variable. Index is set initially to 0 because that's the index that's going to be the leftmost, the first character in the string that we can think of. You use a while loop structure while index is less than the length of whatever string is to be traversed or looked at. Then, if that's true, then do this code, execute these statements. letter equals fruit, and then in brackets the index. So that index number is going to be an integer, and we can use it to look at a single letter in fruit and print it. And then we increment index, we increase it by 1. And so let's give this a try, we'll see how it is. Fruit equals, let's see, pineapple. I'll go a little bit longer here. Index equals 0, so we start at 0. And then we can give that a try. Fruit, 0th index, it's a P. So now if we have while index is less than len, and then inside the parentheses, fruit, see, Python 3 sessions, so I'm going to use brackets in my print statement. Print, we have this letter, forgetting a line of the code here. Letter equals fruit, square bracket index, print letter. And then we want to increment index. So instead of writing index equals index plus 1, I'll just write index plus equal 1. And there we go. So the output is 1 letter on each line, pineapple. We can also traverse a string using a for loop. And this is it's a little bit shorter. You have to use fewer variables. Maybe it requires a little bit of thinking, just figuring out what you want to call these variables. So this is how you set up the for loop. For iterating var, and that could be called anything, as long as it's kind of a legal variable name, in sequence. And there's our string, our compound data object. And then we'd have some sort of statements. So fruit equals apple. For care in fruit, print care. I'll go back and do this. For x in fruit, print x. And there we go, we got the same output. So these two little scripts do the same thing. But for this specific task, the for loop is a lot shorter, it's more efficient. So we still relied on this line of code. Fruit is assigned the string pineapple, the letters in that. But index, this line we didn't need. We didn't need 4 lines, we just needed 2. So fruit, this had to reference the string that we wanted to run through each character in. But this iterating variable can be anything. We didn't need to increment it. It just knows by virtue of a for structure that each one of the smaller parts of fruit is going to be dealt with, is going to be used as an argument here for the print statement. It's going to get printed. Here's a little different twist. So you could have prefixes, capital JKLM, suffix, ACK. For letter in prefixes, print letter plus suffix. The output of that would be Jack, Jack, Black, Mac. So the ACK suffix never changes, but is referenced each time this loop traverses. What does change is the component or the letter in prefixes. So the executor goes through the 0 index first, then the number 1 index, the 2, and the 3. And each one of those gets printed, and when there are no more parts left, then the loop exits. So for loop is useful for when you want your script to run a certain number of times and not to base that on whether or not a condition is true. If that were the case, you would want to use a while loop, but rather if you want to, say, run through every file in a folder, do that. Every feature in a feature collection is for a GIS application. Now, strings are what we call the complex or compound data object. They contain the sequence of characters, but what about integers? Say we want to print hello 50 times. We could not just write that for x in 50, print hello, because 50 is an integer, it's not compound, it doesn't have those smaller parts. If we want to do something 50 times, print hello, what we can use is this range function. And range, which takes two parameters, a start and an end, returns a list of numbers in a given interval. So if we have a variable called seq, sequence, we can assign it the output of the range function with 0 and 3 as arguments. What is sequence? It's what's called a list. So this is another compound data type, like a string, but for strings, the items have to be single characters. In a list, they can be, as they are here, but they don't have to be. So now, if you use the range function to come up with a sequence as a list, marked by the brackets with elements that are separated by commas, you can do something over and over again. For x in range 0 to 3, print, we're on time, x. Let's take a look at that. For x in range 0, 3, print, we'll just print x on this. And there we go, 0, 1, 2. So again, the range function takes it inclusive of the first argument, but not the second. So it goes up to, but not including 3. So why would we want to compare strings? Might be interesting to see if the strings are equal. So really, if you're just doing a text search on files, you want to pick out all the Alabama shape files, for example, or if you want to put them in alphabetical order. And this is possible, but it's something that you need to know about in order to interpret results. So here, two cities in Massachusetts, Worcester and Boston. One begins with W, one begins with B. We can use Boolean operators on strings to evaluate to a Boolean true or false. So for string 1, is it greater than or less than string 2? It's actually greater than, even though W comes after B. And this makes sense if you think about, or if you know how letters are stored in computers, the system for standardized system for keeping track of letters. And that's ASCII. So computers only understand numbers, zeros and ones, and through the placement of those zeros and ones can calculate other numbers and letters. And so ASCII code is a way of representing every character as a number. And there's just a sequence to it, kind of a 33 in ASCII, exclamation mark. 43 would be a plus sign. A 48 in ASCII would be the number 0. Number 57 in ASCII, the number 9. And once letters get started here at 65, it's a capital A. Capital A. And you'll note that kind of runs through so that a lowercase a is actually a 97 in ASCII. So when we're comparing a B and a W, B comes first, but that means it has a lower ASCII number. And actually, a capital B is not going to be the same as a lowercase b. One final thing about strings, and as we see with lists, this is something that's particular to strings. Strings are something that's called immutable. So a string's contents, the items in that sequence, cannot be modified one at a time. So you can't just change a single character in a string. You can do this, or you can achieve that effect, but you're going to need to actually create a new variable to do it. So this is kind of a silly example. We saw hello world as something that kind of the first ever program would print. What if we wanted to change the capital H to a capital J? So we can't simply assign a capital J to the 0th index of greeting, which was or is that capital H. You get an error, you can't modify it. What you do instead is to create a new string. So you take that initial greeting, hello world, and then plan to use it to calculate a value that you would assign to a new variable, new greeting. And how might you do that? Take that capital J that you want and add it to a slice of the initial greeting. So here the slice index 1 colon means start at the number 1 index character and take everything to the right of it after it. So really this is capital J plus the string hello world, not including that H. And what that gives you is Jello world.